So you want to know everything there is to know about AI, but you only have 10 minutes. This is going to be a challenge, but let's see if we can do it. AI, or artificial intelligence, is a branch of computer science focused on building systems that can perform tasks that we would normally associate with human intelligence. AI is not just about ChatGPT. There are several major types of AI models out there in the world today. The first one is language models, which includes tools like Siri and ChatGPT. Siri is much more of a traditional language model, which is trained on a relatively small amount of data to help it understand instructions like set an alarm at 7 AM. The specific model type for Siri is a natural language understanding model, or NLU for short. Tools like ChatGPT use what's called large language models. They are trained on a wider range of text content like articles, transcripts, and code files. This makes them really good at things like generating text, summarizations, writing code, and being used as chatbots. These two tools fall within the same category, but are actually very different. Next, we have computer vision models. These models process images and videos and can be used for things like facial recognition and detecting objects. This makes them great for things like self-driving cars and those automated passport gates at the airport. That's a very peculiar example, I know, but they're useful. Early computer vision models used convolutional neural networks and work by receiving an image as a list of pixel values to represent color. It then processes the list of pixels to try and recognize patterns in what it is seeing. So for example, if the model was trained on 100 images of dogs and fish, it would gradually learn what makes an image of a dog, and what makes an image of a fish. Next, we have speech and audio models, used for things such as converting text to speech to text, classifying sounds, and even generating sounds. These examples that I've given you just now are barely scratching the surface of the range of AI models that are out there. In practice, the underlying techniques that power these models can be applied across each of the different categories, but for now, we are just going to keep things simple. As I mentioned, the most popular form of AI at the moment is large language models, largely due to the wide-scale application that they have had over the past few years. Typically, AI models were only specialized and purpose-built. But with the viral launch of ChatGPT, mass interest in the subject saw hundreds of millions of people start using these tools for more general purpose tasks. Things like writing articles, summarizing content, and writing code. Now that's pretty insane because it's a single tool that can do all of that. At their core, LLMs are massive neural networks trained on huge amounts of text data. Books, websites, articles, and more. They don't actually think like humans, they just find patterns in language and generate text based on that. In many cases, the output is similar or the same as if a human would have responded to an input, but the process of getting there isn't the same. And that's what's important. When an LLM generates text, it uses next token prediction to choose what to write next based on the prompt it was given and what it has already written. For example, if an LLM started generating the following text, it's going to predict the word that is most likely to come next in this sentence based on what it has seen in its training data. So it's not actually thinking, it's just predicting. So now that we know how some of these AI models work at a high level, let's talk about how they can be used and adapted for different use cases. Because in the case of LLMs, they are general purpose models. So if we have a specific use case, we need to figure out how we could adapt the model's abilities to be really good at what we want it to do. There are three main ways to do this. And without these three methods, not only is the model limited to its general purpose use case, it is also essentially frozen in time with its knowledge being limited to what it was trained on. Let's say that you were to ask an LLM for a piece of recent information. It probably wouldn't know the answer because it wasn't trained to have that knowledge. And if it does know the answer, it's just guessing. Here are some ways that you can get around that. Training is where a model is rebuilt from the ground up. If we had hundreds of millions of new pieces of data that we wanted to provide our model with to help improve its knowledge, we would likely retrain the entire model with new data. So if we wanted to update its knowledge to be able to answer our question about football, we would then need to provide it with the information on the match and then retrain the model. That works really well if you're adding lots of information to the model, but it's time consuming, very expensive. In the case of ChatGPT, that means hundreds of millions of dollars. And by the time it's finished, we'd probably have a lot more information that we would want to add to our model, so we would just need to start all over again. Another option for adapting an AI model is fine-tuning. This is the process of taking your new set of data and adding it to the model by tweaking the weights. This would still take a lot of time, but you could yield much faster results and you'd also be taking advantage of the data that the model has already been trained on without having to have access to all of that data. So it's easier if you're taking an existing model and trying to make it better. There is still a faster technique though, and it's all in the prompting. Prompting an AI model is essentially providing it with an input. The way that you prompt your model can massively affect the output that you get, especially if your model is general purpose. This isn't specific to LLMs, but it's definitely most relevant when you are working with them. So how could we get a model to answer our question from earlier by just changing the prompt? I mean, surely if the model doesn't have access to any information on the recent games, it's not going to be able to answer it, right? Well, what if we gave it the answer? Inside of the prompt, we could provide it with the results of all of the recent games, and then all it would need to do is find the result that we are looking for in the data that we have provided. And then it would be really easy for it to answer the question. This is by far the fastest and easiest approach to answering our question in this example. However, if we were to do this for every single question that we ask the model, this could become really inefficient, and there wouldn't be much point in accepting this inefficiency if we didn't have the requirement of data constantly being up to date. So in summary, choosing the method that you want to use should take into account your specific use case. Next, I want to talk about the concept of Retrieval Augmented Generation, or RAG for short. In our example for prompting, we mentioned that you could provide a model with context relevant to your question so that it can use the context to generate an answer. This was a basic example of how RAG works, and it's part of what makes LLMs extremely useful for smaller developers and for businesses who don't have huge budgets to train or refine their own models. RAG is the process of receiving a user's message, let's take this question about Formula 1 for example, and searching records in a dataset which closely match the wording of our question. Using these returned records, we can provide the model with additional context on the topic which could help us to answer the question. As new information is created, you could add it to your database and voila, you have an up-to-date AI model. Now that we've covered RAG, I want to talk about agents and automations, which is the start of more practical use cases of AI where we are taking the human out of the loop. An AI agent is more than just a chatbot. It doesn't only generate answers, it can actually execute actions. That means that it can call tools, run functions, look up information, send an email, or even execute code. Here's an example. Imagine asking an AI to schedule a meeting. Instead of just telling you the best times, it could check your calendar, check your colleague's calendar, and then book the meeting for you. Agents are able to make decisions like these using large language models almost like a brain. For example, you could prompt an LLM to select the tool that should be used to achieve the desired outcome for the user. In this case, it would select the Create Task tool and then use it to create the task. You can use agents to create tools like chatbots, or you can integrate them into automated processes. Here, instead of talking directly to the agent, we could set up a simple automation that is triggered every time we get a new email from our manager. We could ask an agent to determine if the email contains instructions for a new task, and if it does, add it to the task list. There are so many ways that you can trigger automations, but they all generally fall under the following categories. Scheduled tasks, which occur on a schedule that you set. Event-based tasks, which are triggered whenever something happens. Condition-based tasks, which occur when certain conditions are true, even if they are not strictly tied to a schedule or an event. And on-demand tasks, which are manually triggered by a user by pressing a button, for example, or sending a message to a chatbot. Automations themselves are not AI, but they are a really useful way of removing the need for a human to be a part of the process. So far, this video has been really positive and optimistic about AI. So now I want to briefly talk you through the challenges and the ethics around it. One of the biggest challenges is hallucinations. Just like humans, AI isn't always right, and the problem with that is that you can't hold AI accountable for its mistakes. This makes the decision-making process for replacing human decision-making with AI decision-making very difficult in some scenarios. For example, I wouldn't trust an AI agent to answer all of my emails for me because of the risk of hallucinations. But I probably would allow an AI to help me review my scripts for me because there are more steps in the editing process which would allow me to catch any errors or issues with what the AI has outputted before you see my video. And now we're going to quickly touch on ethics. Ethics with AI largely concerns a few main questions. Is the data used to train these models sourced ethically? Just because content is public does not mean that a publisher has necessarily consented to their content being used to train a model that is being used for commercial purposes. Is the model biased? This may not be intentional, but biases in the data that a model is trained on can lead to unfair results when using a model. Should this be regulated? As the use of AI continues to grow, there is a conversation around if the use of it should be regulated to prevent or perhaps slow down the replacement of humans for specific tasks. There are so many different topics around the conversation of AI ethics, and it's quite complicated when you look into the different discussions, so I am going to leave this for another video. I hope that you've enjoyed this brief introduction into AI. If you did, please do leave a like down below, hit the subscribe button if you're new, and tap the bell icon to get notified every time I post a new video.